Fantastic. Well, welcome everybody. Like I said, welcome to our webinar for this week to support Techweek 2022. And I'm actually automatically going to pass over to Thomas.
Oh, so let's go ahead and play. Yeah, we're going to play our little animated intro for our logo here. And I think, yeah, we're going to start right off, kind of just introducing ourselves as well as our company ByteEd here as well. So this QR code just on the screen here, this one I believe just takes you to the website. So feel free to go and have a look at our website either now or later at any time. We've got pretty much all the resources that we kind of have up for offer and plenty of other stuff that we're probably not going to mention today up there as well. So there's lots of stuff to find there. We'll do a quick introduction of ourselves. So I'll start off myself here. So tēnā koutou katoa, ko te wāro te maunga, ko wāwao tu awa, ko whangaruru te moana, ko Thomas Mail toko inoa, no reira, tēnā koutou katoa. So my name is Thomas. I graduated from Media Design School up here in Auckland with a bachelor's in software engineering, as well as kind of mainly doing also a lot of game design there as well. And that kind of led me into a lot of the development in terms of virtual realities and kind of how we can incorporate these kind of virtual realities in a lot of applications, one of which is education. So I really like working with all the different realities. So we've got virtual reality, augmented reality, done a little bit of mixed reality and kind of all that stuff working together. But I am the main kind of software developer here at ByteEd, working on mainly the software side of things, so developing apps, developing demos on our website, but I also help out with the product development when it comes to digital technologies and computational thinking to kind of give my advice on how to, yeah, all those keywords and complicated topics there as well.
So kia ora everybody, tēnā koutou katoa. Ko tapanui te mauka, ko Trenti awa, ko whakatipu wai Māori te rautou, ko Sara washbook toka ingoa, no skunthap aho inari inaiane ke te noho, aho ki tahuna, no reira, tēnā koutou, tēnā tātou katoa. Welcome everybody in this. I don't know what it's like where you are, but as you can see, I live in the beautiful Queenstown, and believe me, it is very wet and very cold, and we've got a bit of snow hitting the hills. I think quite a few of the teachers in this area at the moment are hoping for a snow day tomorrow. There's fingers crossed, but I'm not quite sure whether they'll get it or not. My background is I've been teaching STEM and technology for over 25 years now, both in the UK, but predominantly here in New Zealand. I've gone through all the revisions to the technology curriculum, and I've recently just stepped out of the classroom, and now I'm product development lead at ByteEd. So I help to design, develop and create the teaching resources that we have at ByteEd in collaboration with our team that we have as well. In my own time, when I do have free time, I actually do support technology education too. So I support technology education for students and teachers across New Zealand by being part of 2 subject association committees. So I'm on my last month of tenure for DITA, Digital Technology Teachers Aotearoa, and I'm also on the TENS Council too. I was also very, very honoured. As you can see, there's an image down at the bottom right too. I was very honoured. I don't know if you can see, I don't know if you see my video, but there's a shiny spot above me. That is the Prime Minister's Science Teachers Award, which I was honoured to receive last year. And I'm actually the first technology teacher in New Zealand to receive that awesome award. So very privileged and very humbled by them. So we're going to explore a little bit more now into what we're going to be looking at through the webinar today. So we're going to have a look at who ByteEd are, and so just explore, just to give you a little bit of background to who we are and where we're from and where we're based. Then we'll have a quick skim through what we feel is the future of digital technologies, especially in relation to AR and VR. We're going to explore our brand new resources, so our Play, Code, Learn kits, and then we're going to have a real focus at the one that is it's just being manufactured now as we speak, and in fact it should be winging its way to our shores any day now. So we'll have a closer look at Dinosaur Steps. So this is just a quick overview of what we're looking at today. But I'm going to pass back over to Thomas, and he's going to introduce who ByteEd are.
Yeah, so ByteEd, we're quite a small team that's starting up, and our main focus here at ByteEd is kind of to try and stay ahead of the curve in terms of emerging technologies and to help people kind of understand and learn and teach with these newer technologies coming out, as they seem to be coming out almost every year at this point. So we've got a lot of focus, and we'll kind of jump onto the next slide there with like virtual realities and augmented realities, but anything tech related, as everything's becoming a lot more tech based in the world as well. We would have seen, if you want to quickly jump back one slide, sorry. We've got a few other members on the team as well. So we've got a few other digital experts here at ByteEd too. We've got modeler and animation happening. So we also do offer modeling and animation courses. We've incorporated quite a lot of that stuff in our content here as well. And we've also got quite a few other people who work in the education system, one or two that work in tertiary education as well. So we've got a lot of quite a lot of experts on the team, and we all really collaborate really well together on a lot of these topics, and it kind of works out quite well being a small team, as we can really kind of just engage with each other quite easily. So if we head over and jump on to the next slide now, we've kind of got a little demo video that we've put ahead and created, kind of to showcase what we kind of envision the future of digital technologies, kind of starting off being a learner and someone who just plays with stuff that moves on to them being a creator. There we go. So we'll just let this short little video play out for a moment.
Sorry. I was admitting somebody in. Yeah, so that went into VR mode. You didn't miss much of the second part.
No.
Sorry,
yeah,
Thomas.
so that was just kind of, yeah, a little video showcasing kind of what the, what we kind of see the future of education, taking people from that kind of learning and playing aspect and teaching them how to end up being creators themselves, and especially being creators with the new emerging technologies such as VR and stuff. We do also focus on a few other realities as well. So as I mentioned before, we do a little bit of augmented reality. We've got quite a bit of augmented reality in today's webinar as well. But we've played around a little bit with mixed reality too. But the kind of the blanket term for all of these realities kind of put together and working together currently is called XR. So whenever you hear the word XR, they kind of just mean all the realities working together in one way or another. And more recently, you've probably heard of the word metaverse being thrown around quite a lot. And that is pretty much the same thing as XR. It's the ability to have all these different augmented virtual reality, pretty much all these different realities working together and communicating with each other. And that's the idea behind the metaverse and probably the future of technologies, even if it's not called the metaverse at that point in time. But even now, a lot of these technologies are already working together at the same time, and they're only really just going to work together more and more smoothly in the future as well. So it's kind of a cool thing to kind of learn how all of these different realities work together and the pros and cons between some of them as well. So we can introduce you to the other side of the team as well. So we've got quite a few dinosaurs here to introduce you to with their own names. You'll be seeing them throughout the webinar. These are all the dinosaurs that we use in the kit that we're about to talk to you about today. But it's also kind of just insight into how we kind of develop some of these into actual 3D modeled and animated assets to use inside of these kits as well, starting off with concepts and creating characters, and then actually iterating on that and creating it into a model, and then animating that model and texturing that model. You can kind of see the design process of bringing these characters to life, that again, you'll be seeing quite a bit in our kit in just a moment. In fact, actually, I think on the next slide. Yeah. So this is one of the first interactive experiences. So if you would like to try it out, I highly recommend doing it. So if you do have a mobile phone or a tablet or anything that can scan a QR code, if you go ahead and scan the QR code currently on the screen, it should take you just to a certain page on our website, which has loaded up to it a AR and VR experience, which you can see playing on the screen right now. So if you actually want to explore this video essentially yourself and actually jump in and be able to look around, go ahead and scan that QR code. We will kind of hang on this slide just for a couple minutes, just if anyone does want to give it a go and just to play around with it themselves. It kind of is just a cool showcase with what the current technology can currently do. So you can see Sarah's got it there as she moves the screen around. If you can see her little point of view, as she moves the phone around, you can kind of see that it does also influence where the camera is looking. So it is a fully fledged out VR experience that you can look around and see everything in 3 dimensions too. So this is actually using a framework called A-Frame. And this is entirely free to use as well, A-Frame. It just plugs into any website. It just uses HTML-based codes. It's actually, there's barely any code. It's just some basic HTML blocks if you know them. And you can drop in, and you don't actually need to know HTML. You can actually do a lot of this without HTML just by moving objects around. And the cool thing is it's completely free. Don't need to download anything like massive engines or anything like that. This is all really accessible too, which is really awesome. This also works in AR as well as full-on VR modes. If you've actually got a VR headset plugged into your computer, you could actually use that right now as well and actually view the world in real space 3D and actually feel like you're there with a headset on your head as well. So it's really cool, this framework. And again, it kind of starts to introduce you to the ideas of how all of these things can kind of work together and all the different realities that we have.
I hope everyone noticed the pterosaur flying over the head as well.
Yeah.
It's probably, they're everywhere. Dinosaurs are everywhere.
If you want to try this out later, or you just don't have a phone on you at the moment, it is all on our website. And I believe these demos are free as well. So you should just be able to go to our website. You can also do it on the computer. You don't need a phone to do it. It's just a little bit cooler because you can look around, but you can completely have the same experience using a computer screen as well. So you can just go ahead and try that later too. All right, so I think I'll pass it back to you, Sarah. We can talk a little bit about the STEM kits that we have.
Oh, thank you. Yeah, so what we're going to do now is we're actually going to have a look at the main group of resources that we've been designing and creating over the past year, and they're called Play, Code, Learn. And we're trying to look at a series of STEM kits that have progressive learning of computational thinking, digital technologies, whilst being integrated with lots of other curriculum subject areas too. So we've been focused on a Dinosaur STEM series, and we're going to have a real big focus on our first of the series, Dinosaur Steps, in a little while. But we have created this as, like I said, as a progressive learning opportunity for students to be able to learn either at home, so they can learn at home with their families or on their own, or they can actually learn in a classroom environment. Some of the main reasons that we're different to other digital technologies resources that are out there on the market now is we try to be obviously very, we use a play-based learning approach. So we incorporate lots of different teaching methodologies that actually are utilized in the classroom today. We also combine unplugged learning with digital. So we help with that progression of learning so that students have a hands-on practical approach to actually learning the key concepts of computational thinking. We're also one of the few companies that actually incorporate augmented reality when it comes to teaching computational thinking and programming. So we are a little bit different to a lot of the other kits that are actually out there too. And we also have supportive resources, teaching resources to help with the teaching using these kits too. So their main points of difference. And obviously our key point of difference is we're actually based here in Aotearoa. So we always try to integrate and weave in Te Reo Māori in the key concepts to normalise that as part of our normal experience of actually who we are. So why Play, Code, Learn? Well, we have these 3 main concepts, and they come together because they're based on quite a lot of different kinds of research that we've done. They're based on our own teaching practice. Those of us who are educationalists actually in the team, we've actually used quite a lot of the different activities and methods that you're going to use in the kit with students and with children. So we have experience of all these different kinds of approaches, and we've tested and trialed them, and we've seen what's engaging for learners. The Play Code Learn kits, the ideas that we wanted them to have is we wanted them to have progressive learning, so they learn the basics but gradually build up that knowledge as they work through the series of kits. We also wanted to obviously enable that growth mindset. We're trying to deepen problem solving skills, logical thinking, building resilience, so that if things do go wrong, the students actually learn, or the children actually learn, that they can actually resolve those issues that they've got, and they build their resilience by doing that. I'm not going to read everything on the list there, but these are the key ideas and the key concepts that we do have. And we also try and make sure that we link our activities, our teaching activities with the kit to real life experiences, so that the students actually can understand and they have that authentic learning coming through too. So when we bring all of those key ideas that we brainstormed down as a group together, we came up with an identified Play Code Learn as our series. So what does that mean when we break that down? So the play part is actually focused on our play-based learning pedagogical approaches, which obviously is very popular in classrooms today. And I know that there are different ways and different ways that this is actually being taught in the classroom. You've got that full immersion in play aspect, or you've got the teacher-led learning through play. And this kit actually will help to promote either of those initiatives or viewpoints, depending on how you teach in your own classroom, or how you encourage learning through play at home as well. What we've got here is we've always tried to do some background research to support our key concepts as well. So you can see that we've actually found a few different aspects here of research to help to support that too. But what we want the students to do is, as you can see, this is some examples of Dinosaur Steps and Dinosaur Loops, but students are learning through a hands-on practical approach. They are communicating with each other, they're collaborating. It brings all those other key competency skills, or those employability skills, to enable them to be great citizens of the future. So that's what we try and incorporate through our series of kits too. So how can we do that? So here are just a couple of examples of how some of the kits that we've got actually incorporate play. So like I said before, we always have a very hands-on practical approach. So whether that is with a jigsaw board, as you can see, in Dinosaur Steps there's a Jurassic land, or Loops that have Jurassic tiles where they can create their own lands if they want to. We also have cards and hands-on practical things that students can actually use and have a physical representation to use algorithmic, I can't even say this today, I'm losing it now, sorry Thomas, algorithmic thinking. So we can use the cards to be able to do that too. But then we also have different digital aspects where the students can actually learn through play too. And this is really where our augmented reality comes in. So as you can see, they use these cards and they can actually see a three-dimensional dinosaur, and they can play with that dinosaur if they wish to and move it wherever they want to. We have animation, we have sounds, and we also have the ability for students to potentially take photographs of the dinosaurs. So you can actually incorporate this with science or history, and you can ask them, what would this particular dinosaur like to eat, or where would they hide from somebody else, like a T-Rex? And what they can do is they can actually go outside, so they can go anywhere and actually use this app, and they can take photographs of these dinosaurs in those environments where they're answering those questions to help support. So we've got lots of different ways to actually, and these are just a few of the different ways that we're actually supporting a play-based approach, which is very hands-on for learning too. So the code part obviously is introducing computational thinking in digital technologies. And we do that through a variety of different teaching methodology approaches. So we have our unplugged activities. So as you can see in the image there, we have students who are using these directional cards. So this one's actually steps. So it's a very basic introduction, and they're looking at sequential instructions. They're looking at how to write an algorithm. They're looking at debugging and solving problems. And they're also starting to look at decomposition as well. So they're starting to use these simple cards, which are obviously sustainable resources that we have here, and they start to create their own unplugged activities. But then we also, not only do we have the unplugged side, we also transfer into a digital format as well. So they take their knowledge that they have learned and those key concepts they've learned by doing something hands-on, and they take it into our own ByteEd app, which Thomas has been fundamental in designing and creating. So you can see there you've got your sequential instructions, and you've actually using the Dinosaur board and augmented reality, and you're actually helping the students to learn how to program. There's always this key question that comes through: why should children learn to code? Well, there's more research. There's lots of research actually out there which actually backs up this point of view of why coding is actually important for our students. And you can see that really it is all about becoming logical thinkers, problem solvers, and being able to be future focused citizens too, with that ability to be able to use that to build on their digital literacy. So this is our approach to DT teaching and learning, and we base it on the SAMR model or SAMR model that people use globally in different teaching environments. So the key aspect is we're taking students from the substitution, number one, and we're trying to guide them through down to modification and redefinition. So the key idea that we have is we want to take them from being users of digital tools. So for example, just using something and scanning it in AR, for example, or putting on a headset and just having an experience in VR. Another example could be substitution is, if you're doing any kind of handwriting at all, so they've written a story, all you're doing is you substitute it for a Google Doc or a Word document. And so that's basic substitution of a digital tool with an analog tool, essentially. But what we want to do is we want to deepen knowledge content and knowledge creation for our students. And the way to do that is to move them up to modification and redefinition. So in those areas, we're in that transformation phase, and what that does is it enables the students to either create with digital tools, or it enables them to create actual digital tools. So creating for problems and solving issues. And that's what we try to do as we build up through the kits. They're starting to be much more creative and much more progressive with their learning, which will deepen their experience and hopefully engage them, but also build on their knowledge and being able to transfer their knowledge to other aspects as well. So once again, here are some examples. We've mentioned a couple of them. So you can see on the left, this is our Dinosaur Steps kit. And you can see there are students working on unplugged algorithms. They've plotted paths. And what they're trying to do is they're moving Explorer Ed. You might have seen our little robot. He actually sits in a Jeep and he drives around. So we're actually moving them around the board too. And then that transfers into the programming aspect. Now, the difference between Dinosaur Steps, which is the one in the middle, to the ones on the right, which is Dinosaur Loops, and this is that progression of learning. So this is Dinosaur Loops is the next kit on top, or the next kit along, but you can see there's a big difference between the coding aspects. It's very simple in steps because you're just building up that knowledge of sequential instructions. However, in loops, that's where we really start to bring in iteration, so using repeats and using loops. And so our progression is actually really based quite clearly on the progress outcomes for computational thinking in the New Zealand curriculum, and linking to other standards across the world in this space too. So we're on to the final part, which is looking at learn. So our kits, not only do we want them, you can obviously see really clearly, we've got clear links to computational thinking and digital technologies, but we don't just want the learning to stop there. I've seen very clearly in my own teaching experience, being in primary and intermediate and even secondary schooling, that we need to try and make sure that we integrate other subjects, because teachers, once again, are time poor, but we've got to make that learning real, and we've got to have that transference of knowledge from one subject to another. So how can we do that? Well, one way is by obviously linking to STEM. And so we do have a STEM-based approach. So we do link, as you can see, these are just some of the examples of how we're linking to different STEM subjects. But not only do we do that, but in our teaching resources, we also try to have other curriculum subject links as well coming in too. So you can see here that we not only do we have literacy, we also have numeracy coming in here, we have measurement, we have design, we have obviously science, we've also linked to dance and arts and all these different things to try and actually build the knowledge and the use of the actual kits themselves. So all the kits will actually help to aid that transference of knowledge from other areas. So like I said before, we have 3 kits actually coming out in the series. We have Dinosaur Steps, which is made, and like I said, it's on our way to us now. So this is a product that is about to be released onto the market. We've got Dinosaur Loops, which is in our prototype stage, and then we're moving into our Dinosaur Commands. So what we've got is we've got these 3 kits here, and they all introduce different aspects of computational thinking, and you can see the progression through. So it's very simple and very basic for Dinosaur Steps, but it introduces those key concepts, and it actually builds their technological literacy. In Dinosaur Loops, we introduce other terminology as well. So inputs, outputs, pattern recognition, for example. And a lot of these can also link to the technology curriculum as a whole too. And the same with Dinosaur Commands, that's when we really start to introduce the next step up in programming, which is looking at variables and comparative operators. As you can see from the grid at the top, we've tried to aim the kits to once again have that progression of learning. Just to know, Dinosaur Steps, we have actually used this kit, or I've actually tested it. We're down to actually 3 years old, even though we do suggest from about 4 upwards. But 3-year-olds actually, it's amazing what some 3-year-olds can do when they get hold of an iPad or a phone nowadays. So it's very intuitive. They can actually scan these dinosaurs and they can use them, and they can start to press the buttons and start to make instructions and make the Jeep moving. So they can actually start to use these kits very simply, which is awesome. And it's very engaging. They want to go back and use it again. And as you can see that the kits themselves, yeah, you have got that progressive learning. It is the year levels are so wide, and purely because it really depends on the knowledge of the students and the knowledge of the teacher who's obviously teaching it, or the family member who's actually running through the kit with the learner at the time. So yeah, that's why they all overhook each other, but also show clear progression too. So just a really quick recap about the Play Code Learn series that we have, and we have other kits in our strategic planning coming through too, to develop the progression even further. But what do we want them to do? Well, we want them to help children, and we want to help them to learn to build their learning to learn skills, so the students can actually work on their own, either at home or in class if we wish to. We're obviously trying to build those problem solving skills and those key skills they need for the future, and also we're also trying to build their literacy too. How does it help families? Well, it's not just something to entertain the children at home. It is an educational product, but it is fun and it is engaging, and they can, once again, they can do it on their own, or they can do it with parental or family support too. And finally, how do we help the teachers? Well, obviously, it's once again, it's building those key skills. It's helping to support different pedagogical approaches that we have in our curriculum that we use. It integrates with literacy and other curriculum subject areas. Obviously, it's preparing our students to be future-focused digital citizens of the future. And it's also, like I said before, weaving in Te Reo Māori as well. So now what I'm going to do is I'm actually going to pass back over to Thomas, and he's going to just go into a deep dive, really looking at the Dinosaur Steps kit itself.
Yeah. Cool. Oh, there we go. So yeah, we're just going to have a quick look more into depth about our very first STEM kit, which is Dinosaur Steps, and kind of why we've kind of decided to choose some of the things that we've done. So we've kind of had a brief, not so brief, but a pretty elaborate, explanation to kind of all the things that we've been doing here at ByteEd and how we're incorporating them into our kits. But if you are interested in the STEM kit specifically itself, so Dinosaur Steps, this is kind of how it works a little bit. So we start off with that play-based approach, where at the beginning, the very first thing that they actually need to do is to construct a jigsaw and actually put the board together. And they can do that as a group, all working together to construct it. Not too difficult, but sometimes it does take a while. And sometimes it even took me a while, sometimes if I've got all the tiles around the wrong way. But after they've got the board set up, that's when they can move on to the kind of the coding side of things. So the main focus on Dinosaur Steps is that very first introduction into computational thinking, which is understanding algorithms and how they can use algorithms to or use sequential instructions to create an overall algorithm. They use this by using all the kind of the tiles that we've gotten provided in the kit, so they can place tiles on the board, map out their route that they want to take, and then they've actually to convert that route into a set of instructions. So you can already see them progressing from laying out their step-by-steps and then actually having to convert that into a set of directional instructions in a certain order as well. They can also do this as a group, as completely usable as and it's actually probably better to be used in a group as well. And it actually allows learners to focus on a few different things at the same time. You know, one person could be focusing on constructing the route, one can be focused on turning it into an algorithm, and then the other one can actually be focused on communicating that algorithm back to someone else, which is actually quite an important skill to have when it comes to understanding how algorithms work. So then we've got a video there as well, kind of just demoing them playing out and using the kit.
Right, right, up, left, up. We have reached our destination.
Cool, so you can kind of see it all there working together, how they've got the pieces laid out on the board, but you can also see that she's reading the algorithm there as well, step by step, and how that moves everything around, and how she's communicating those steps as well, which is a very important skill in programming, being able to communicate what you're thinking correctly. I've worked with other programmers before, and if they're not good at communicating, it's quite hard to understand what they're trying to tell you, because you pretty much do have to break everything down into little steps and then convert that into programs and algorithms. So it's actually a really important skill to know how to turn that into a set of easier instructions using decomposition. So that's quite a cool bonus that they get to learn as well.
And just so people know, while I was filming then testing, and what you didn't see just before this was actually they'd just done a swap over of who was reading out the instructions, because these are year 4 students. So this is at the upper age level that we designed the kit for. However, some of these students didn't actually know their left from right. So so it enables those other skills, and like Thomas said, to actually build up that communication. So actually they do actually read the instructions correctly too. Yeah.
Cool. So let's talk a little bit more about using the AR side of things as well. So this kind of comes into a little bit about the play aspect, but it also comes into how we can actually fundamentally use our apps on our phone that we've developed to actually allow you to turn your algorithms into programs and actually input your set of instructions into a set of digital instructions that the app will then follow. And it all works using AR technology. So that's kind of why we had the demo before, showing you the ability of AR and VR working together. But the app here specifically works with AR. So we do have another interactive section here on this page if you haven't seen the QR code in the corner already. So if you do go ahead and scan that QR code, again, it's just going to take you to a page on our website. You can access this manually too if you just want to go to the website and have a look at it later. But this one does require you to have a mobile phone or tablet for it to operate correctly. Because what it does allow you to do is it allows you to scan the tile that we have on the slide screen here as well. So of our flying dinosaur here, where it says Augmented Reality Dinosaur Card. If you go to our website, scroll down a little bit, so you've got a little window that pops up. It probably will ask you to if it can use your camera. And then you should actually be able to scan the card on the screen here and actually see how the augmented reality function works. Sarah, you might just need to move the little box slightly off the tile, just for this slide, but I just might make it a bit easier for others just in case they want to try scanning it there. But this is fundamentally how the app works in terms of augmented reality. We just use trackers in this form of our little cards. You can see in the video playing in the center there, as well as the tile that we've got up on the screen there. And just by holding up their phone or their tablet up to these tiles, they can actually have everything pop up into augmented reality. And it teaches them how that works too, and how that moving the camera around and moving the phone around, they can also kind of see everything move at the same time. Even the board itself that the dinosaurs are put on top of is technically a tracker as well, because it has a virtual world pop up off the board too. I think you've probably seen some of the screenshots of it before as well, but it is quite a cool, everything working and connecting together. And they actually communicate together as well to construct challenges and things like that. So that's a little bit about how the AR side of things work. And again, you can try this again later, I think. But you can always have a look at it on the website, or you can always jump back and try the other demo as well. So another thing that we focus on in the first STEM kit, and all the other kits as well, is the literacy when it comes to digital technologies too. So we've got lots of different options for lots of different learners and also lots of different abilities, but these options are also for teachers as well, depending on their confidence level. Some people might find it actually really easy to jump into some of the other stuff, where some teachers might just jump straight into the complicated stuff as well. So we've broken it down as much as possible to kind of provide you with a variety of different resources to use. The first one that we've got there on the left-hand side is our easy to read instruction cards. I think Sarah's holding some up there as well. And these are essentially just there's no text on them. And they're just used for visual references only. They've pretty much just got diagrams and pictures on them just to make it easy to kind of understand the steps needing to take to kind of use this kit. So again, for those people who might not be able to fully read large amounts of text or anything like that. On the majority of our pages as well, we do also have more QR codes. We like to use those. These will take you to linked audio files as well. I think Sarah's holding them up. We've got a booklet of instructions there too. These QR codes will take you to an audio file that will play. They'll actually read out the instructions, or the entire page, I should say, for you. So you can actually audibly hear the instructions being read out as well. And I think we've got a few different options there too, if you'd rather have the audio option there instead. Otherwise, all the key terms that we do use in the text, we break down photonically as well, and we also highlight just to make sure you understand what are digital terms or digital technology terms and computational thinking terms. And yeah, as we said before, we broke it down photonically, so it teaches you how to pronounce those words as well, giving you even further confidence in the kind of literacy of digital technologies. I do believe we also do have a glossary as well. You can always revisit and see all of those keywords that we use as well. So yeah, we do like to try and make sure literacy is a very good and well covered topic in all of our stuff. And Sarah, I'm not sure if it was in those slides as well, but do we have Tadeo in there as well for some of the keywords?
Yes, absolutely. Yeah. So all the key terminology for digital technologies and computational thinking is also in Tadeo. Yeah.
Awesome. Cool. And kind of the last thing, just to have a quick look at in the Dinosaur Steps kit itself, it's a little bit more on the app side as well. So we talked about how the AR technology works as well, but the and that just kind of brings the physical STEM kit to life and allows them to do the exact same stuff. But because the app can also have lots of other stuff loaded on it, we've decided to go put some extra stuff on the app as well. So we do have some challenges that you can use through the app too. These challenges are essentially just pre-laid out positions on the board that you need to go from start to finish essentially while going past the dinosaurs on the board. So essentially the first couple of levels or challenges are just like constructing a basic straight line in an algorithm. And then it starts to get more difficult the further you progress. It starts introducing corners, then it starts introducing collectibles, and then it starts introducing multiple corners, obstacles, and things like that. So it's a way to kind of just go through the app and just progressively challenge yourself, learning more and more, constructing these more complex algorithms as you go. We do also have a glossary of dinosaurs on the kit there as well, so you can actually learn a lot about the dinosaurs that we've got inside of the kit. You can view them in 3D and AR as well. You can actually spin them around, which we thought was just quite cool, so you can see the full 3D model They're all animated too. You can actually tap on them and they play animations. So we've made it as fun and engaging. Again, going back to that play aspect, while also teaching them quite a lot as well. And I'm sure many kids, especially their age, will be kind of familiar with the layout of like a game-like screens and things like that. As Sarah was saying before, they just open up the app and they understand it better than anyone else straight away. We've got a video there as well. I think they can just quickly play as well. And this is just using the app again. I'm kind of using the app from start to finish, how you can construct it, how you can see it moving around, how it works together, and how everything scans together. So I do have to say this is a slightly older version in the video. The colors are not that intense in the final one, but that is kind of how the app works itself, how you can scan everything and yeah, construct your algorithms and see them play out in real time in AR as well. So you can actually see all that too. Cool. So Sarah, do you want to talk a little bit more about what's included in the Dinosaur Steps kit? So obviously we've got the physical STEM kit. We've also got the app. But it also does come with a few other things too.
Awesome, thanks Thomas. Yeah, so as you can see, this is what's actually involved in the physical kit and in the app. The other thing that's actually in here is you can see that there's Chompy's challenges. So Thomas showed you in the app that we have got challenge lessons that are digital lessons, which should progressively get harder for the students to work through or children to work through. Well, we've actually got an analog version as well, so that learners can actually work through those too. That's actually part of the kit as well. So you can see that if you don't have very good Wi-Fi, like on a night like this, you might go down, you might be in the middle of the South Island somewhere, you can actually still use this kit no matter what you've got available, because the hands-on practical bit enables the students still to learn even without digital access. So we have all those different aspects. We have the kit, we have the app, but not only do we have that, we're actually include in a whole package more teaching resources for teachers in the classroom or potentially for people at home. Who knows when we're next going to go back into a lockdown again, and we need to, I know what it's like having my own children, how hard it is to work and to teach and to look after everybody and make sure everybody's learning at the same time. So there are some other aspects that we actually support you with too. So these are just some of the different extra resources that we have. So number one, we're in process of improving our website. So we're adding lots of different teaching activities and resources for you as teachers to take into the classroom, explaining how to teach computational thinking. Because I don't know about you, but I know that when I've bought digital technologies tools in the past, whether it's robots or Arduino-based boards or 3D printers, I've gone into the classroom and I've gone, right, I've got this robot, what do I do with it now? And it's been a big learning progression for me to be able to think, right, well, what do I do with it? So what we've done is we've taken that away for you and we've provided all these different resources to actually help and support. So like I said, we've got this interactive website. It has lots and lots of different activities using the Dinosaur Step kits and the whole series, teaching people and breaking it down into computational thinking concepts. So there are activities to help to support teaching algorithms, pattern recognition, decomposition, abstraction, and logical thinking. So they are things that you can either download and use in your classroom alongside the kits, because they actually are fully integrated. And they're just lots of different ideas for you. In the top right hand side, just underneath either my image or Thomas's image, I'm not quite sure what you can see, but we've got the challenge activity cards there. So these are a series of printables that you can obviously download, print, laminate and use. They cover, there's 8 challenges for each computational thinking concept, and you can use them as extension activities in the classroom, or you can use them to help to support understanding of decomposition, say. The activities in there are differentiated, so there are some easy activities and obviously there's some more difficult ones, and they all come with an answer card, which you can see just at the bottom image there, and that gives the students the answer to the puzzle that they're solving, but also it explains really clearly what the computational thinking is and why it's important. So not only does that help students, but it also helps families, and it also helps teachers who actually don't have that knowledge in this space. The other resource that we've actually got available for you is we've created a 10-lesson unit of work to help to teach computation and thinking. So this is a resource that you can just take and use straight away without actually having to do any planning yourselves. It's a whole new resource that you can use yourselves. It also has 5 optional curriculum integration lessons as well, just with some ideas, and there's more ideas for integrating Dinosaur Steps on the website as well. Included in the kit is we have a very detailed overview and unit plan, which is looking at the progression of learning in computational thinking. It's every single lesson is broken down very clearly with learning intentions and the activities that can actually take place to teach that particular concept. Supporting each lesson, there are teacher handouts. So handouts that you can print off and you can give to the students, and they are fully differentiated as well. We have beginner, intermediate and advanced levels in that work. And then we also have teaching slides as well that you can use to help to present the knowledge to the students too. At the end of every lesson, there's always a self-reflection too. And then obviously you've seen in the kit and on the app, we have got challenges as well to enable the learners to practice what they have actually learned about too. So there's some examples of extra resources. So I said we're actually giving you this as a whole package. It's not just a physical kit that you actually take and use. There's much more to the access of this too. Obviously, integrated learning is really important at primary level. What we have done is, as you can see here, this is just for the Dinosaur Steps kit, but you can see the different integration and some of the examples of the activities where you can integrate with other subject areas too. So you can see some of the ones in black there at the top, they're the ones that are integrated into specific lessons, and then the extension activities are actually at the bottom too. So there's lots and lots of support to actually help with learning that way as well. I'll let you read through some of these testimonials that we've got from actual real life teachers out there across Aotearoa. So as you're reading through that, I'll also just tell you that not only can we support you with extra resources to help teaching, but we can support and provide PLD if you have a school or a team that actually want to actually have the help to support you in learning how to teach computational thinking and digital technologies. We can do that for the kits, or we can do that separately as well. I am actually an MOE accredited facilitator in digital fluency for ByteEd. So actually you can actually apply for funding too from MOE, from the national priorities. So if you did want to go and follow that approach, you're more than welcome to do that too. As you can see on the board, we get some real life, I always get teachers to test and trial the kits. And so they obviously give us feedback and help us to improve as well. As you can see, we've got a wide range of different types of teachers. So we've got people who are very specialized from digital technologies and have been teaching Digitech for a very long time and are very well known for their teaching experience as well. We've got new entrant teachers here. And so that was Maggie's students down in the bottom corner there. She was impressed with the kit, not only because it was teaching computational thinking, but her students could just go for it. She wanted to actually use it in the class as a standalone kit, so that the students can actually go in there themselves and work on it by themselves. And then this is our final testimonial here. And obviously this is our upper age range for the kits too. So this was Lara, and these were some of her students too in year 4. And as you can see here, not only was she enjoying the fact that it teaches digital technologies, but also it was helping with behaviour because the students were fully engaged. They were doing collaboration in small groups. There was literacy involved. And these are things that she identified as being positive points for the actual kits themselves. So how to get hold of a kit? I know some people might be interested in this, but like I said, as we speak, they are winging their way to us, the first Dinosaur Step kits. Please keep an eye on our website. So there's the link to our website and had the QR code earlier. If you lose this, and don't worry about it, I will be sending out an email after this webinar, which gives you an overview of all our links as well. And I'll actually send you screenshots of those interactive slides too, so you can still have a go with the VR and the AR if you want to as well. But this, if you keep an eye on our website, or I'll show you some other ways to keep in touch with us as well, it will be announced when the kit is actually here and it's ready to be released out into the community. So this is now your chance. This is your chance to ask any questions. If you've got any questions for Thomas or myself, if you want to pop anything into the chat, please feel free to do so. And obviously we're here, we can answer any questions that you have. I'm just going to open up the chat. So just if there's a box appear on the screen,
yeah. We've had some questions in the previous times we've run this webinar, and some of them have been like, what other things do we offer for the students of higher age ranges? Because some teachers, you know, are teaching year 7, 8, 9, up and like that. On our website, we do also have other modules and courses. It's not related to Play Code Learn, which is why we haven't talked about it today, but we do offer other modules that teach computational thinking with text-based programming. More kind of aimed at that year 7 to 8 level, or again, depending on the level of the learners as well. And we've got a few modules that go through quite a few stuff there as well. We also offer 3D modeling and animations. If you want to kind of jump on the creative and artistic side of digital creation, we've got modules, they're available as well. So we do have quite a few other things for offer.
Awesome. Thanks, Thomas. We've got a couple of questions saying what they make their tiles and things made from. Well, these are actually cardboard. So we're trying to make our product as a sustainable product as possible. Also, our product is our ByteEd product is now trademarked as well, a New Zealand trademark. So we are a New Zealand trademark company, which is awesome as well. So yeah, we're trying to make things as sustainable as we possibly can. Has anyone tried them with sensors? Yeah. So when I was in testing and trialing the kit, so we had a mixed range of abilities that actually came in. We had students who struggled with literacy coming in. Because of the hands-on practical nature, I think you could use them with a wide variety of different, of diverse needs that are actually in the classroom itself. Because it is engaging for the students, I would hesitate to put some SEN students with the VR goggles on at the moment, especially at this age group, but the AR would be awesome. It's very engaging for them. They can interact with the dinosaurs in the app too. So yeah, it's very diverse and has lots of different ways to encourage things. Yeah. Oh, we're using VR at school, works awesome. Well, that's brilliant now. I think there's a lot of controversy with VR at young age ranges. There's lots of different research out there which can be conflicting. Some of it is very, very supportive, and some of it is not too sure at the moment. But I think it's still a watch this space, because VR really in schools, it's only really just starting to actually get grips, and most of it's experiential learning with VR as well. So the students put obviously the VR headsets on and they're taken somewhere else. There's not as much of creation with VR. There's a little bit, which is actually deepening, and obviously that's where we want to take students to.
How to use this technology more than just, well, create, sorry, I should say, with this technology more than just using the technology itself. And kind of understanding how quite a few some of the things that we've been talking about today is actually quite simple to do. Like the A-frame experience with the dinosaurs, again, that's just using HTML, which if you're considering, you know, a programming language, or you've kind of, you know, done some other stuff before, you've probably heard of HTML. It's one of the more easier kind of programming languages out there. And you can just use that to construct your own AR and VR experience with very little other code needed. So it's getting a lot more accessible too, which is awesome. And I think that's the main thing that it needs to be to get into schools more. Because right now there's quite a lot of walls behind creating with certain softwares and stuff. So even if you guys got any questions on those, like what softwares would we recommend, or programming languages or anything like that, we can help you out with that too.
And
Sarah, do you just want to flick to the next slide as well, just while we're talking?
Yeah, absolutely. So, good question. Good idea. I'll just close the chat for the moment so that I can. Thomas, you might be able to open up the chat, so keep an eye on that for me.
Sure.
But just another little interesting aside. We say we're trying to hook and engage the students. Another way we've tried to do that is by. You might have noticed on one of the first slides we've named our dinosaurs, and they've all got really interesting, funky little names, really. But that's because the dinosaur names actually link to some of the characteristics. So I don't know if you see this little wee character here. This is our Parasophilus, and he's called Wumph. And there's a reason why he's called Wumph. And I don't know if anybody knows, but the crest on here on the head, that's their main communication tool for when they're actually talking amongst the herd. And the sound it makes is a Wumph sound. So we've tried to make lots of different kinds of learning opportunities, even with just the names of the dinosaurs.
Yeah, we've had a lot of fun with them. We've even come up with some more interesting names for future dinosaurs too.
Future dinosaurs.
Yeah. We've got a question here, which is, when is this going to be available?
Yeah, so like I said, we're hoping that it's actually going to be landing on our shores any day now. And so what we're doing at the moment is we're working with a main distributor. And so as soon as that's actually being finalized and sorted out, I'm hoping within the next month to 2 months. So pretty soon. Yeah.
That is the hope.
That is the hope. Yeah.
We do have quite a few kits coming in from overseas though, so we will have I think we'll have a pretty decent stock.
Yeah, absolutely. Yeah. Are there any other questions, Thomas?
Not currently.
Okay, cool. Awesome.
If you guys, so if anyone thinks of any questions as well, obviously after that, sometimes it's always hard to think of questions on the spot. You've got all of our contact details, and you can find all the information on the screen right here now as well. So you can go to our website, you can visit us on all of our socials that we've got there. Or you can just flick us emails as well, and we're more than happy to reply and help you get started. Or if you've got any just digital questions in general, we'd love to try and help out. And
yeah, absolutely. And the only thing I was going to say is if you want to have a go with any unplugged activities, there are lots of resources out there that you can actually find. But if you're looking for something in particular, like I said, a lot of our resources are tested and trialed, or the Dinosaur Steps unplugged activities are tested and trialed on things. So we do have some things available on Teachers Pay Teachers. We've got a ByteEd store there. So if you want to get your hands on some and trial some unplugged activities, which are the same kind of idea but a little bit different, and then feel free to jump on there. You can have a look at those. And everybody's got my email because I'm the main person that's been contacting everyone. So if anybody should wish to contact me in the future, obviously just flick us an email through, and we will follow up the webinar with, like I said, an email to you, just recapping some of the main developments in here too.
Yeah, we've got a couple more questions. Just one, the first one, which is, does the QR trigger the AR or the app? So the QR codes that we've got on the slides, you can just use a typical phone scanner. So most phones will have it as a standalone feature. Some phones you might just have to download an app that's called QR code scanner, but you don't require the app to try out some of those AR experiences and VR experiences that we've got on the slides. But using the app and using the actual dinosaur trackers, that does require the app, which comes with it for free. Well, it's actually a free download anyway, but yeah, we give you a license with the package as well. The other question was, will there be a package deal for the kits, or do we just have to purchase kits separately?
No, it will be a package deal for the kit. So we're trying to aim to set something up. So if you buy one kit, you get the physical kit, the access to the app, and the access to all the resources on the website. So it's pretty cool. And then we're also trying to work with our distributor to actually, if you want to say, because I know what it's like being in a STEM classroom, and if you have one kit, then students go to one kit, and sometimes you need 5 kits to spread around the classroom. So we're trying to set up so that if you want to buy more than one, like a certain amount, that we'll actually try and set up some kind of package for that too. So that's a work in progress at this precise moment, but obviously as soon as we get updated with that, we'll let you know.
Cool. I think that's currently it for now.
Fantastic. Well, thank you everybody for joining in. If there is anybody who wants to stay and ask a question, you're more than welcome to. But I must say thank you. It's been awesome to have everybody on board tonight. I know it's not the nicest thing to do sometimes, have things in the evening, but we just wanted to open up this opportunity for everybody who wanted to actually come and attend at a different time and couldn't make it during the day. This webinar has been recorded, and watch your space as well, because we do hope to host this recording on the website as well. So there's that information for you too. But yeah, have an awesome evening, ka kite, and hopefully we will see you or hear from you all in the future.
Yeah. Cool.
And I'll just stop recording.